Okay, so first we're going to look at number 13 from tonight's homework. So number 13 says, it takes a force of 109 newtons to lift a stone straight up. So we're going to write our given. And I'm not really sure what to call that force. I'm just going to call it FA for applied force. Why am I calling it applied force? Because remember, like a push or a pull is an applied force, so since I'm lifting it, I'll call it FA. It gives the stone an acceleration of 12 meters per second squared. Calculate the mass of the stone. Now, first of all, I want to draw a picture of what's happening. Okay? So I can draw a free body diagram. Now, a free body diagram always has a box to represent the object. A dot in the center represents the center of mass. And what I do is I show all forces that are acting on that box. So I know that this force lifting it up, which I call the applied force, FA, and that's 109 newtons. Okay? Then I have a force acting down, which is the weight, which I call FG, which I'm going to have to calculate, but I know that's equal to mass times gravity. So that's my free body diagram. It shows all the forces acting on the object. And this is important because I really can't work this problem unless I have that picture. What you're going to see in this chapter is I have to draw a free body diagram for every single problem. Once I draw that free body diagram, it makes my life easy. Okay? An important thing that I have to do is I have to establish my sign convention. So my sign convention is up and to the right is positive. So when I look at this picture, anything that's going up is positive, anything that's going down is negative. So on this one, let me just start. There's two things that there's one thing that I have to do on these problems. I'm going to apply Newton's second law. So Newton's second law says the summation of F net is equal to MA. So what does this mean? Well, the summation sign, this is a Greek symbol, and this doesn't represent an unknown variable. This tells me I'm doing something. This just means I'm adding up all the forces. F net is like the net sum of all the forces going in a particular direction. And those are equal to mass times acceleration. So when we were in middle school, we learned F is equal to MA. But now that we're in high school and we're doing physics, we're going to have more than one force. Does everyone see on this diagram we have more than one force going in the y direction? Okay. So now we're going to apply Newton's second law in this y direction. So how do we do that? So first, again, I'll rewrite that. But before I write this, what I'm always going to do on every problem, because I'm going to add forces vertically, and on some problems I'm going to add forces horizontally, and then on some, when we get to some forces, we're going to do both. Okay? And remember, we're starting off slow. So first I'm going to draw my sign convention. So my sign convention, I wrote a plus, that means positive. Then I drew an arrow going up, and that means I'm going to call up positive. Okay? Now I'm going to apply Newton's second law, and I'm going to say summation of F net. Now, instead of calling it net because I'm going up, I'll put y, because I'm adding up all the forces going in the y direction. And that's equal to mass times acceleration. We're going to be doing this over and over and again. Now, what I'm going to do here is, this means I'm adding up all the forces going in the y direction. So instead of this now, I look at my free body diagram, and I look at all the forces going in the y direction. Now everyone sees FA is going up, so according to my sign convention, up is positive. So now I'm going to write FA F of G is going down, so that's going to be negative. So the signs here I take directly from my free body diagram. That's why it's important to draw these going correctly and make them going in the directions they actually act. And then I leave the rest alone, is equal to MA. Now, sometimes what they do in some books, some high school books, they try to oversimplify, and they just come up with this equation. And they're like, okay, and they call this the working equation. But they don't explain where it comes from. See, when you understand something instead of memorizing it, no matter what problem we do in this class, no matter how difficult you think a problem is, it's not going to be difficult because you're going to understand it. You're not memorizing something different because there's too many different scenarios. All right, so now we're basically home free, and what we're solving for here is we're solving for M. Now what I can do is I see that I have M here, but f of g, you see how here I didn't calculate f of g? Why? Because f of g is what? M times g. So obviously I'm going to have to do a little algebra here and simplify. So I'm going to leave FA alone. I'm going to put the FG on the other side, so I'll have MA plus FG. All I did was add it to both sides. Now I know FG is equal to MG, so I'm going to simplify that. And now it's obvious I can do what? I can factor out an M, right? So FA is equal to M times A plus G. And now I know FA, I know A, and I know little g. And if I want, I can put that back in the given. G is always going to be negative 9.8 meters per second squared. Now, in this case, I don't actually have to put the negative sign in because when I drew my picture of this going down, that's where the negative came from. So now I'm going to rearrange this algebraically, and I'm going to solve for M. So M is equal to FA divided by G plus A. So that's equal to 109 newtons times 9.8 meters per second squared plus 12 meters per second. And again, the negative here already took into consideration right there. See that negative sign? That's where I factored in the negative for that acceleration due to gravity. So it's already been counted. So I don't put the negative in again here because the negative has already been accounted for right there. See that? So I don't do it again. So then when I substitute in my values, this comes out to be like 4.95, but we'll say that it's 5 kilograms. And that's it. So that is number 13. Okay, now we'll do number 14. So number 14 says a 60-kilogram boy and a 40-kilogram girl. So I'm going to call this MB for boy, and I'll call this one like MG for girl. Or I'll call this one 1 and 2. That'll make it easy. Oops, sorry. So this is 40 kilograms. Engage in a tug of war on an icy frictionless surface. If the acceleration of the girl towards the boy is 3 meters per second squared, so this is the boy, this is the girl. You know, the more you write down on paper, the less likely you are to make a mistake. So make sure you say, okay, I'm going to call this M1 and this M2. So it says, if the acceleration of the girl toward the boy is 3 meters, determine the magnitude of the acceleration of the boy towards the girl. Okay? So what I want to do is I want to draw a free body diagram. And they're kind of pulling like this. And actually there's, oops, I didn't draw this right. There's not a box in the middle, I'm sorry. They're each pulling on this, and when we have a force in a rope, remember the lab we did Friday? What do we call a force in a rope? We actually call it tension. And the thing about the tension is that the tension or force in the rope is always the same everywhere in the rope. So if it's one rope, there's one tension. Okay, it's not going to change. So the tension or force in the rope is always the same, just acting in different directions. Now, later on, we might have more than one rope, okay, but right now we're just starting off. So it's one rope. So what we're going to say is we're going to apply Newton's second law and say F is equal to ma. So F is equal to 40 kilograms times 3 meters per second squared. So the force is equal to 120 newtons. So the other force is the same, but in the opposite direction. All this stuff I'm writing is just the explanation. You don't have to do that part. Okay? So now I'm going to apply Newton's law again and say F is equal to ma. And I want to solve for A. So A is equal to F over m. And if I'm calling this positive 120, then, one way has to be positive and one has to be negative. When you look at a tug of war, isn't one person pulling one way and one person pulling the other way? So I'll just call this negative 120 over 60 kilograms. And 120 divided by 60 is 2. And that's it.